So, hello everyone, welcome to the new session of Understanding It Like a Pro. Today we'll be discussing about RNN. But before starting our session today, let's start it with one of my favorite quote. So it is from a movie Batman, where Batman is very disappointed. He thinks that he had failed. Then Alfred tells him that why do we fall, Bruce? So we can learn to pick ourselves up. So this is the theme of our session today. So whenever the problem comes up, we will not just give up, will not get disappointed, we'll try to fight it out, we'll try to solve that problem. Let's see how this theme persists in our session today. Okay, so before diving really deep into RNL, let's start with a game. If you win, you can skip this video, and you can go on and chill. But if not, you have to be with me till the end. Sounds like a deal, right? Okay, so let's get started. Close your eyes and repeat the English alphabet in the sequence they occur. Easy, right? I already feel like losing, but wait. How about repeating it in the reverse order? Just give it a try. I can see you sweating already. I think we are continuing here, right? Cool. So with this, what I wanted to bring into your notice is that how we learn. So we learn alphabet as a sequence. Let's term this as a sequential memory. Sequential memory is a mechanism that makes it easier for your brain to recognize sequence patterns. Let me stress this with one another example. When you read any text like essay online or something like that, you understand each word based on your understanding of previous words. You just don't throw everything away and start thinking from scratch again for every word. Your thought has some persistence. So this was the issue with earlier, like neural network in the starting days. So there was nothing as sequential memory in them. So but with RNN, they use this concept of sequential memory. So if you are familiar, if you would have heard about normal neural networks, so it looks like this feed for a neural network. Input will come, hidden layer it is like hidden layer will be there, and then there is the output. So now the next question would be, how do we introduce this concept of sequential memory in this neural network? It's a good question. So if I'll give you a time, like what do you think, what can be done to introduce something like that as sequential memory into this normal network? Perfect. If your answer is looping, it's the right answer. So yeah, so the answer is looping. So this is our RNN, if you'll see. So this is a loop, like this is the highway or something like passage of the message, whatever it has learned to its successor. So this is what we want, right? To pass the information to its successor. So yeah, so now let's if we'll unroll it and try to understand it, what lies behind it, or try to build some analogy. So it can be thought as of multiple copies of the same network, each passing a message to its successor. So if like same network is there, multiple copies of the same network, and each of them is passing the message to its successor. If we will unfold this particular thing, it will look like this, right? So I think we had enough of visualization of like how this RNN looks, basically what changes it had been made into this so that it will look the RNN will look like that. But I think you really want to know the next thing, that how it basically works. So yeah, so let me just show you from a blog I have. Okay, yeah. So let's just take a sentence. The sentence is, what time is it? Okay, and see how this RNN like will feed to it, and what our objective is for feeding this sentence is that we want to find out the next word, like, or let's say we want to find out this question is asked, and then there is something chatbot or something like that which will answer to this question. So this is our objective, let's say like that. So first the sentence is, what time is it, will we feed it to RNN, and then the answer would be given, something like that. So now the sentence is, what time is it, we'll break it into words. So every word would be fed into the RNN, and you will be getting some encoding. Okay, and hidden layer would be passed to the next layer. Similarly, it will pass, like all things would be done, and similarly you'll get the final output here, O5, and the final hidden layer you'll get. Okay, so this is how it will happen. So for every layer, we feed the new word and the hidden state from the previous step, and this is how the RNN will learn the information. So yeah, let me go back. Okay, so it all looks good and fine, right? But don't you know that nothing is perfect in this world? So let's see where RNN fails. Yeah, so if you remember the last the last hidden layer of the RNN, it looks like something like this, right? Yes. Okay. Yeah, it's here. So yeah, this is how our RNN, like the last hidden layer of our RNN, look like. So this color in them are not there just for fun, or are they? Let's see. It tells about the biggest shortcoming of RNN, that is short-term memory. From our last example, like what time is it sentence that we feed it, let's just take that example. And so if you see this hidden state, it has more portion of is and it, and with negligible portion of what and time from sentences, like from our previous sentence. So if I'll just show you the sentence again, so is and it has more portion in the final hidden layer as compared to what and time. Okay, so this is the problem of short term memory that RNN faces. In theory it can learn like long term dependencies also, but in practical we are not able to see that particular thing. So do you like, are you able to see what is happening here? As the number of steps increases, RNN faces problem in retaining the old information. You know who is the culprit here? Let's find out. Okay. Yes, okay. So before that, I want to tell you, let's just discuss about how the training of neural network works. So training of neural network has three major steps. First step is it does a forward pass and makes a prediction. Okay. Then the second step, it compares the prediction to the ground truth using a loss function. The loss function outputs an error value, which is an estimate of how poorly the network is performing. The third point is it, it uses that particular error value to do back propagation, which calculate the gradient for each node in the network. Okay, we adjust the network internally, like we adjust the internal weights of the network based on the gradient, which allows the network to learn. Okay, I'll show you also so that it will make more sense. Yeah, so this is how the gradient will flow to the previous layers. Okay, and it, like the gradient keeps on shrink, as I've already told you, that we adjust the network's internal weights based on the gradient, right? So that the gradient, as you can see, it keeps on shrinking to the like as it moves towards the earlier layers, it keeps on shrinking. So as the gradient shrinks, so do the adjustments made to the weights, like depending upon the gradient only we make the adjustment to the weights, right? So as the gradient shrinks, so do the like adjustment made to the weights, and so do the learning of the earlier layers. So what basically it means that due to back propagation, when the gradient moves toward the earlier layer, the gradient value decreases. So the changes that are made into the earlier layers, that also decreases, and the earlier layer learns less as compared to the other layers. So that is the reason what time the and RNN is not able to learn, but it is able to learn properly. So if I'll ask you, is it? What will be your answer? You won't be able to answer anything, right? So how do you expect an RNN to work on that? So as a like, so I think this will make like what is like it will make clear to you that what RNN faces as a major problem. Okay, so here is a problem. So as per our theme of today, whenever there is a problem, we need to solve it because we have a Gotham to save. So what are the solutions? So the solutions are LSTM and GRU. Okay, so what is LSTM now? So LSTM are special kind of RNN that are capable of learning long-term dependencies. So that was the problem with the RNN, like the traditional RNN. This has this same problem, that they have a short-term memory. So LSTM are able to learn the long-term thing. So the LSTM also have this, like the similar to the normal RNN. They also have this chain-like architecture, but the repeating module has different structure. I'll just show you also. So this repeating module, if you can see, this is a different structure. Instead of having like single neural network in like that was present in the traditional RNN, they have gates. Okay, there are four gates are there, that like these gates will are a way to optionally let information through, like okay, what information that we want to forget, what information that we want to remember, which information will have higher weightage, something like that. All those things are taken care by these gates. So these gates are like different neural networks, and they can also learn as per, like when you train your this neural network, these gates will also learn, and depending upon that, they help this particular LSTM, or which is a special case of RNN, this LSTM, to learn the long term dependencies. So now the final hidden state will have a good proportion of what time also, as compared to is it when we come as compared to the not traditional RNN. Okay, we'll get into the like I think this had made clear what is basically RNN is. Then what's the basic shortcoming of RNN, that is short-term memory, and how we can solve it, like how is it been solved, that is LSTM and GRU. Okay, we'll discuss them in detail some other day, because I actually got a Gotham to say. So now coming to the part of Rockstar of this week. So this week Rockstar is Priyaranjan Mohanty. So he's working as a delivery manager, and he's like an integral part of AI Charcha family. He has done a lot of Udemy courses, and you can find him interacting with many people who are actively working in the field of data science and machine learning, in in an effort to learn new things, and also to support them in whatever way he can, so that they will be continuing on their journey. Now come the next question is how you can be the rock star for the next week. It's very simple. All you have to do is to help and support the community. If someone is if someone is facing doubts, if someone is not able to understand things properly, you can help them, and you can also use this particular thing for your own benefit. You can work on projects, you can work on whatever hands-on that I'm posting, and you can just share it on the LinkedIn with a hashtag as AI pe Charcha. I will personally review it, and if I find it original and worthy enough to be shared with the network, I'll definitely do that. And I'll also share your profile like this. So I'll be waiting for your participation in that. Till then, goodbye.